So, good morning, good evening, and good afternoon to all the viewers of GroundBreakers Transforming Geotech. We're back from a quick summer break, and we have a brilliant engineer and also now consultant civil engineer from the field with us today, Mr. Todd Roberts. And currently, he's serving as the associate principal and vice president of monitoring and IoT services at the Digital Technology Solutions area of GZA Monitoring. He's based out of Denver, and the company is based out of headquartered in Boston. And he has a lot of experience in monitoring, whether it's on the product development side, to the more engineering side, and now the more project management consulting role. So, Todd, it's a pleasure to have you here with us today, and I'm very excited to share your journey and insights with our viewers.
Thank you, Ritvik. Glad to be here.
Yes, so I think I've raised a bit of a high mark on your career journey. So let's start with your career journey today. So you've had a very big transition from really being involved in product development and selling products to a more strategic project management role. So what really motivated this shift from being that engineer to the consultant, and what are some of the key moments that really define the journey while you were building a product, selling it, and now being on the other side? And how do you feel at the other side of the table?
Yeah, it's a great question. I think this is a great starting point for this discussion. My journey is a little bit bigger than you summarized. I actually started as a geotech engineer out of college. Started off with materials testing, testing soils, asphalt, and concrete. Worked my way up an engineering company to drilling boreholes, project management, managing and running a lot of the drilling operations. Along that first phase of my career, I started installing sensors, and I really liked that part of the business. I think it gave me an opportunity to apply my fundamental geotech background and my geology background, and then apply it to the practice of instrumenting the soils and the structures. That really, intrigued me. Really brought a lot of interest to my early career. And the company I was working at was not, devoted to the monitoring space. So about middle of my career or so, I got recruited into the manufacturing side. Long story short, I got recruited by a startup company called Sensemetrics that had a hardware and software component. What attracted me there was it was a plug and play type solution where I didn't spend a lot of time configuring and building my own logger devices, but rather I bought an off-the-shelf product that enabled me to connect a sensor, install it in the field, give it power, and then return to my office. That whole workflow, for lack of better description, it's a lot like a smartphone where I could just connect. It just worked, and I could focus on the next job, not worrying about setting up systems. That was a real big attraction to me. Over the years, Sensemetrics is very successful. We were then bought by Bentley Systems, along with Vista Data Vision, Eagle IO. That trifecta of monitoring solutions allowed Bentley to engage in the IoT business and connecting sensor data to different products that Bentley had, iTwins and other applications. That ultimately opened the door to evangelize the monitoring industry across the civil space and mining spaces. What I realized was I was really connected with the sensors in my head anyway, the sensors, the connectivity, the software, and how people could buy and leverage it. But I felt a little bit that the industry was advancing faster than the adoption on the owner side and the consultant side. So I saw an opportunity for me to, sharpen my skills going back to consulting and taking the technology that I've learned over the years and applying it back to the industry. That's what led me back to GZA.
Yeah, it's a very interesting journey. And I think the plug and play, the easy to use, is something that we're seeing all over the world with monitoring. And just to move into it a bit, so when you say you move back and now you mentioned a bit of the gap in adaptation, because we see a lot of software being developed, a lot of wireless data logging, but also wired on the high speed data logging being developed. So how do you feel we can bridge that gap? Because I think that gap has to be bridged by people who understand the technology, but also by people who are willing to use the technology.
Well, this industry is a big machine, and there's different cogs of the
Yeah,
machine. And
yeah,
one cog is development of software, another cog is development of connectivity, another cog is sensors. A fourth cog might be the execution of those solutions into
yeah,
practice. That would be an engineer typically. And then
yeah,
another cog would be the owner.
yeah.
You have to get all the cogs aligned together so they're spinning together and moving the machine efficiently. So it isn't just making a software platform or making a sensor. It is enabling the engineer to understand the value, how to position it, what the pros and cons are, and then engaging with the owners so they have procurement abilities to buy the technology. And we
Yeah.
can invent all the technology we want. If there's no procurement vehicle to buy the technology, we're never going to get it into the market space.
Exactly. So it's really selling the value of monitoring, the importance of monitoring, and then also making it easy to obviously use, but also enter into procurement and also the project requirements. I think that's a
Yep.
pretty good way to put all the five cogs together, and alignment is really important. So I think moving on from alignment, over the past 2 decades or three, we moved from actually writing on paper, monitoring to then Excel and various different softwares to now platforms. And now we have AI, machine learning coming in. And IoT has played a big role in it, the Internet of Things for people who don't know. So can you share some key milestones on how these technologies coming in from tech mostly have helped us in civil engineering and construction? And how do you see this journey moving forward?
Sure. This is a little bit of a complex storyboard. So I've actually prepared slides that I've been using in the past year or so that kind of complement the story, the narrative part. This is the visualization
Yeah,
to the narrative. You know, having worked in the consulting space and in the manufacturing space, I compartmentalized the components of our monitoring ecosystem. At the bottom where it says monitoring ecosystem, when you work left to right, there's the sensor component, and then you have connectivity, and then you have different forms of data management. And this, the data management part of it speaks to the last maybe 10 years of evolution. But the sensors go back decades to the 40s and 50s and 60s, where sensors were first conceived and put into practice. Some of those sensors are still operational today. They're very reliable. Not a lot of change happens at the sensor layer. On the connectivity column there, or that layer, there's been a lot of change. When you look at 15, 10, 20 years ago, we were running wires to, home running them to a logger station where we had data collection. Sometimes we had data automation, but it was wired based systems. Today, we're leaning more heavily towards wireless, and it may vary by regions in the globe, but generally speaking, the industry is trending towards wireless solutions. Some of the reasons for that trend are increased reliability in wireless transmission. We've had time to test them out and get adoption. There's been the relatively stable pricing for the connectivity of wireless solutions. And the cost of labor has gone up pretty high over the past 5 years or so, which combats well, if you're using labor to install wires, there's a direct cost increase there. But if you're using wireless, you're reducing that cost associated with high labor. So a lot of the connectivity is evolving, and new technologies like LoRa, mesh radios, things of that nature are becoming available. Satellite comms are becoming more in reach with things like Starlink and Crucial. And then you have to do something with the data. Just collecting data and
yeah,
storing it isn't enough. You have to manage it. As my daughters say, in the olden days, the 2000s, we used to use Microsoft Excel sometimes, or we'd
yeah,
use programs that were devoted towards data management. But in the software space, as I would define it here, it was very limited in what it did. It supported
yeah,
maybe a single sensor. Maybe it had reporting. Maybe it did not. Maybe there was a fee. Maybe it was a no-cost application. And there was different software applications that were, siloed into that realm. But at first, they did not. That's all we had at that time.
yeah,
When I joined Sensemetrics, that was one of the first companies to really build what I would call a platform. A
yeah,
platform has additional criteria, different performance criteria, different features. One of the main criteria would be bilateral communication. In other words, field to office to field workflows. You don't have to leave your desk to do anything. You can just look at 3 or 4 projects, send a command back in the field, change your reading frequency, take a picture, things of that nature. Platforms enable that. Another main point of a platform is it tries to be sensor agnostic. It tries to read as many sensors as it can, so the engineers are now in control, the owners are in control of the story that's being told by the sensors that are commonly sourced by different manufacturers. One thing worth noting in the platform space is our civil space, our monitoring space here that we're talking about is what I would call infrastructure or mining specific. And the
Yeah.
logos that are in here, which are not exhaustive, just a good representation of the industry, cater to purpose-built applications in the bridge space, in the dam space, in the mining
Yeah.
space, in the tunneling space. Some span different verticals. Some are very hyper-specific in one area. But they're distinctly different than the agnostic approaches of Microsoft and AWS, where they give you tools to go build your own experience.
Yeah.
You both are viable. It depends on how you're positioned as a company to engage with either of those two platforms. And then more recently, what I probably say was probably 2023, 2024 onset and beyond, the use of big data. And I'm using the big data describer here or description as a catch-all for all the different analytics that go beyond what a platform does. And you can talk AI in there, machine learning, predictive analytics, but it's a really closed AI application. It's solving for a specific
Yeah.
problem. And there's a few companies that are starting to engage in that. And I think as we look to the future, we would expect, growth in that area. But this
Yeah.
from end to end, from sensors to big data, includes the 3 major components: sensors, connectivity, and data management, which a sensor integrator will then capture and deliver as a service. And then you're now enabling a larger asset management workflow.
Yep, I think this is a pretty great insight, and it puts, of course, it's not an exhaustive list, and it puts a lot of the big players and people are trying to challenge the status quo in the industry in different areas because, as you said, big data is going to be the future, whether it's just putting generative AI in or machine learning algorithms, or even you have 1,000 sensors in a couple of projects, and no one's going to look at the graph of all 1,000 sensors. You need to know what's happening when it's happening, and you need to, I think the interaction with the software will also be something different in the future, how we interact and use the software. And again,
Yes.
something that we've also been discussing is how do we bring edge computing onto connectivity? How do
Mhm.
we maximize the output of these data loggers, whether it's high-speed data loggers that get 2,000 samples per second for strain gauges on bridge, or LoRa transmission or mesh to do edge computing so that the processing on the software becomes more and more relaxed and we can actually use it more for analysis, more on like a technical cloud infrastructure point. So I think there's a lot of progress that's going to come, and you put it in very beautifully. And I think for our viewers, you can take a snapshot of this and really use it if you're looking at solutions. And I think a lot of companies are now going to be, if we do another podcast in a year from now, we'll see a few more into big data, a few more into platform. And I think, as you said, sensors, vibrating wire technology has been there for decades, and every manufacturer is pretty much the same today. It's like a Coke Sprite problem. But when you get the big data or the platform, and then you're actually giving Jack Daniels with Coke, which gives the differentiator.
Well, we
So
need
yeah,
competition. Competition is good. It
yeah,
drives change. It drives innovation.
exactly.
Without it, we stall.
Exactly. And the more we push, the better it is. So I have
Yep.
a quick follow-up to this. So like we've seen we're in 2024 right now. Where do you see 2024 to 2029 going? And then where do you see 2024 to 2034 going? So what do you envision as your monitoring toolkit in 10 years from now, 5 years
Mhm.
from now? And how do you see the buzzwords like AI, digital twins,
Yeah.
integration of INSAR with instrumentation evolve?
I think it's going to grow in addition to evolve. And what I mean by that is everything we've done historically is largely going to remain intact and relevant. Vibrating
Yeah,
wire sensors, piezometers are dominant in the industry across all industries. Um, Inclinometers, tilt meters, wireless nodes, they're all going to remain effective parts of our business. But as we look to the future, and technologies continue to grow and innovate, we're going to find new use cases for things like remote sensing applications. I see the use of cameras being a big growth area for us.
Yeah.
That's where then AI and machine learning can step in, because you have huge data sets, NSAR, robotic total stations, GPS. They all generate gigantic data sets that are hard to process. Even platforms struggle with it. And how do you make decisions based on these large data sets that, challenge a human's ability to ingest that information? We're going to leverage machine learning and AI algorithms in a controlled way that will allow us to predict outcomes in the short term, maybe in the midterm type range, where we can look at the ability of looking at a California storm system before it hits the Midwest of the United States. You might have 3 days of advance warning, and if you have the right sensors in place, you can predict outcomes, you can predict behaviors, and you can work with the owners and his stakeholders, maybe first responders, to have emergency action plans or action plans to respond to a landslide that engages with the Department of Transportation. The ability of marrying these sensors together and then engaging with more intelligent sensing capabilities like remote sensing will then enable us to engage with AI and machine learning. You also mentioned edge devices. Edge devices are an increasing technology to be used across the industry. In our space, it's been rather slow, but it's starting to emerge more and more. I've had the privilege of working with one of the products. And what an edge device is an intelligent device where you embed control and you put it in the field. It often has local processing, which gives you the ability to execute on commands based on certain criteria you embed in it. That can be efficient in areas that are cut off from cellular reception. It could be beneficial on a weekend when you have a skeleton crew running at night, or maybe nobody running at night, and you want the ability to turn on your sensors based on a rain event on the project site and take readings every minute. This type of edge computing provides extra value. The one thing about the big data column that I showed before is big data needs clean, quality data sets that have been scrubbed of anomalous readings, that have been cleaned of erroneous readings, false readings, and take that information and make conclusions for us to rely on. When we do that, we need large data sets. So we're going to have the ability of generating data sets, curating them, storing them, cleaning them, authorizing them, and then making them available to the big data algorithms that process them.
Yep. And again, on the big data, I agree with you then. Also, you need to also look at the different conditions of sites. So we have many, many projects in the Middle East and a couple of projects in North America. And when you're working in those environments, the sensors and data loggers work very differently in terms of the environmental conditions and for that data as well. And I think the big data model accuracy will depend on the amount of data we get. So I think it could also be a collaborative effort in the industry to really be like, okay, these are the data sets we have from all these connectivity providers, because those are the guys who give the data, and let's train a community-based model if the open sourcing logic works. But I think that's a large stretch because we're a very competitive industry. So it's going to be very interesting on the approach the industry takes as a whole together on AI safety, on predictive. Today, we're dealing with infrastructure and lives. Predictive is really good for early warning systems, like you mentioned, if you could predict a California storm and move on. But in a deep excavation project, until we're not 100% sure, prediction could go wrong and cause a lot of problems. So I think it's understanding that balance and controlled is a very key word to start with. And as these systems become smarter, as these large language models become smarter, as our data becomes better, I think these tools, whether it's hardware or software, will really help us monitor our infrastructure in a much more efficient and proactive way.
Agree.
Yep. Okay, so I think we've covered a bit of your journey. We've talked a little bit about the new technologies coming in, a bit on remote sensing. But I think let's focus the last segment of the podcast really on your experience. So one thing that I've noticed with my minimal few interactions with you that you really value innovation and you really value collaboration. Because even with GZA, what you're doing is you're looking at that big platform and you're like, okay, how do we use the best combination and how do we work with people to innovate and iterate the solutions better? So how do you really foster that culture of innovation with the people you're working with and also within your teams?
It's a great question. There's a lot of technology out there, as you said. I think we got to go back to the basics. What is the problem we're solving for?
Yeah.
Understanding that, understand the value and the pros and cons of any one sensor is also very important in the equation. Sourcing the sensor and then making sure that the client gets exactly what he wants out of it. And then making the system that you deliver, the monitoring system you deliver, evergreen protected. And what I mean by that is, we're not just building it for year 2024. We've thought about the future so that if the client wants to make a change, he has the best solution that will accommodate that change at the least cost possible.
Yeah.
Those are important basics. And then I think it's important to also understand preparation. Different sensors have different requirements. Some have to be bench tested before they're deployed. Some have to be dusted off. Some cables have to be inspected. Labeling your cables if you're using them at great length is important at distance and the ID number of what it's connected to. Preparation is always critical for proper execution in the field. So if those are the basics, they've always been the basics of monitoring. They're still relevant today, but now we need to fold in the innovation part. What technologies are changing and how does it benefit the clients that we're selling the solutions to? And our team is fairly sizable at GZA. We have huddle ups all the time. Every week we meet. We're meeting vendors all the time, understanding what the latest and greatest is. Sometimes we're asked to test equipment for vendors, which we're honored to do. And it gives us exposure to the latest and greatest so that we can deploy things in confidence with some knowledge base.
I think it's sticking to first principles and then using the technology we can in the best way possible and then trying, testing, improving. I think that's also something that innovation team at Incard and Procure also focus on is really innovate, iterate, and then as we do services in a lot of areas globally, we test them on our projects and then we take them outside. And I think it's really the method that a lot of companies share. And the civil engineering mining landscape is really now becoming a little bit more inclined into technology because it's easier to use today. Yeah. So I think my final question is that there are a lot of young engineers, a lot of young prospective civil engineers who like structural, transportation, geotech, but monitoring is a niche within a niche of a niche industry. So like what is something that you would like say to the young viewers here that would be like, this is something we should try out. This is an industry we can check out.
Yeah, that's sits close to me, that question. That's where I started my journey over 15 years ago on this IoT space. And I think for young engineers, we just don't want to do the same thing your predecessor did. We want to do something what they did plus something better. We want to enhance it. We want to be more efficient. Sensors collect data and to answer observational method requests efficiently. And if we can do things at greater good at a better price point and be more efficient about it, we're going to be in a better place to take the technologies to market. So for those that want to be techie in this conversation, the IoT part of civil engineering attaches information to an asset. We can read it by the hour, by the minute, by the second. We can take that data, we can process it and draw conclusions a lot more efficiently and a lot faster than what we were able to do 5 or 10 years ago. And the more people we can get into this space, the greater good it will be to enabling things like digital twins, big data applications, emergency response, actions, and then the ability to overall lift up the industry and provide value.
I think that's a great piece of advice. And your last thing, lift up the industry and provide value while we pay our debt to society because we are in a industry where we are monitoring structures that we humans and other species on Earth use every day. And when it comes to dams, it's fine if a dam fails, like you can rebuild a dam, but you can't rebuild the surrounding areas and communities in the same way. So it's really beyond just the asset on what we do. Yeah. So I think brilliant conclusion. It was a pleasure talking with you today, Todd. Thank you for sharing our journey, your insights on the key buzzwords, technologies in the industry, and also ending on a very important note that I think a lot of us believe in is how do we take the industry forward together. So I really appreciate it, and I look forward to sharing this discussion with the geotech world. So thank
Thank
you.
you. Thank you for having me.
Thank you. Thank you.